Hey everybody, I have a lot of slides, so everything will be available at the end of the talk, and it will be a PDF file. So whoever is interested in asking questions or want more detail, we can look at that at the end. So I will go it like a chat, explaining more like an idea and what we did. So my name is Enrico. I'm a researcher at the University of Saskatchewan, and I will share a little story about what we did for a project. It is an ongoing research. So we do research and development in cybersecurity, and we do a bunch of stuff, network, malware, software, and devices. And we're working with Chair for Research for Canada for Security and Privacy. So the idea was take document and try to see if you can make a profile for other attackers and defenders, and how far we can bring the idea by mapping the connection and the relevant information in documents. So what we did is an idea of collect documents, collect how the documents are related to the neighbors of the target, interconnect the documents with public sources, then try to find which document can link other documents or entities, and then jump from the target to the nearest neighbor. So the idea is basically 6 steps. We start from a web server that contains some document, and the document are supposed to be linked to something. So we have a target and a surrounding environment, and then we have the entities that are related linked to the target. So the link, we're going to find it from the documents and from the traffic flow of the DNS traffic and some other type of communications. So again, in theory, simple. In practical terms, there are no real tools, so we have to develop our own set of tools to try to make this idea work. So we collect a document, then we use DNS to find information, and from DNS we get the information from BGP and ISPs. Then we look for the neighbors of the target that are the service provider, ISPs related to the target, and companies that are providing services, network services. Then from the document, we find the information on who is dealing with the target and who has any contact that is easily identifiable from document metadata, not from the content of the document. Then from the metadata, we repeat the process by looking at everybody, and then we try to see if we can find a weak link in the supply chain. So it means in whoever is dealing with our target, without doing anything directly against the target or anything directly against the supplier of the target. So we start from the web server. From the web server, we go and we wrote scripts that basically makes use of a specific syntax like Google Docs to find documents that have been publicly published, they're exposed to the internet, they have been uploaded by the owner, and they are in public domain. From these documents, we extract metadata and we parse manually the metadata of the documents for OpenOffice file or Office file to see if we can get something more out of the metadata that is not being decoded properly by other tools. Some of the XML format documents, they're basically zip files, so you can, for example, XLX files, docx, you can rename it as zip, decompress it, and then you can analyze the content. From this, we use, basically we tested the 100 website using normal tools and using our tools. And then we download the document that we found, and we got around 20,000 documents. And what was interesting for us is that almost every document have metadata that can be used. And that more than 60% of all the document we found, regardless of the type of the document, they leak some kind of data that can be used for attackers and should be used by defenders to make sure these holes or this piece of data are not easily exploitable. So which kind of stuff can we find? Well, you can see in many cases computer name, username, login ID, login name, first name, last name, full name, and in many cases also the type of operating system used, the type of software version used, and software type, how they edited the documents, and in some cases, full email address, LDAP, Active Directory IDs, Kerberos IDs. And then we have the document types. So why this piece of information are important for this interconnection of documents? Because on the most basic piece of information that we have is that almost all the piece of data have been leaked. They contain either a specific software type, an internal username, and the revision times. And these are very useful because once you know the username and the software, you can start building targeted attacks. So in many cases also we have the full name of the person or the internal names of servers and workstation. And the email, we get sometimes the internal email and sometimes the public email. Now, just to give an example, in one case, one corporate entity published files. Literally in 5 minutes, we find from the PDF, Then from the PDF, we got the internal username, email, operating system. Then we find that somebody published this document actually was recorded in mailing list that have been hacked, and like dubious, not business content, put it lightly. And then we find their lawyers, and then we find the professor that helped write the document that was connected to the lawyers. This is in the public domain, but it's not easily seeable. You cannot see it, you cannot detect it, it's not readily available. You have to dig a little bit. Another case, this case was like 10 minutes. From the PDF and the document, we extract the metadata. This time we got internal username and the mail. From the mail, we find the alias. From the alias, we got to the PR company that was hired by the government entity to write a report. But the PR company was connected to a company that provided web services for government, and from the web services, we find the OS type, version, and all the detail of the implementation. So why is it important? Because if we take this and we start to have the same idea for the DNS, we go from the DNS and we have the trust documents and the trust link in the DNS, the delegation. And we have like a lot of the information for the delegation. And we can see the flow. From the flow, we can say, okay, who is going through this flow? So I'm flying through the slides because this is like more an idea. So when we throw the information from the DNS to the providers, we have BGP and ISP. So there are entities in the planet that are ISP, that are RIR, that are Internet Registry. Each continent has its own registry, and they provide a lot of data free of charge. So if we read the data, we can create the real map of the traffic based on the networks, and we can see the interconnecting elements across all the networks. Then from the network, we can find the internet connectivity, the DNS, and the web servers. Once we have this information, we can go and repeat the process of, okay, now that we know the interconnectivity and the related servers, we go and we link all the pieces together. So connecting the elements from the 100 entities that we selected randomly, 70% leak DNS, 60% leak IP, 40% leak email, and 22% leak internal IP information. And if we repeat again for the suppliers and in third-party sources, then you start to build a network of information. This can be started with normal tools like Spiderfoot, or can be done manually, and this is what we did. So what did we get from that? That once we start to have the piece of information that is available to everybody, and you can have a little bit manually and another bit with automated tools, then you can start to build attack profiles and defense profile. Now, why is this relevant? Because now we have two aspects of the same problem. From an attacker point of view, we have why should I do all this when I can simply scan the target? Well, the target is not going to see you because you're never touching them. And what you're looking for are information that are connected to the target, and they're not under the same security level of the target. It's most likely, and 90% of the time is, much less secure, much more vulnerable, much less complexity. If we switch and go from a defender perspective, then why do I have to do all this stuff if I can hire a pen tester to test my network or to see if I'm okay? Because if you take in consideration only the legal boundaries, then you're looking only at yourself. You don't know what are the trusted links that you think are trusted, but they are not really trusted because they expose vulnerability and they basically make holes in your security network. So what we did for this is, okay, if we take all of the information together, we build a map of all the information and we correlate all of this and use machine learning to glue all the pieces together. As soon as we did that, then what we find that machine learning can actually help. And what we did is, okay, if we know it helps and we know it works, can we get, for example, cryptographic libraries? Can we know what kind of technology they're using and how? So the answer is yes, you can do it without attacking the target, simply using public information. So here we use standard Python machine learning tools, and we can guess which kind of crypto library they use 60% of the times. And if we know, depending on which kind of information they disclose, we can know from 60 to 93% of which kind of library they use, specific on version, subversion, major and minor. So why is this interesting or why this is relevant? Because all this is hidden, but it's still in plain sight. You can hide your traffic, but in this case, if you hide your security details, you cannot hide the content of the document that you publish yourself. And if we go to look at the information that are interconnected, that basically is DNS traffic, BGP traffic, ISP communication, and your business links, and we use documents instead of attacks as glue, then you can do literally a document mapping. You map documents to security features and to security implementations. And from the document, you can see the technical detail and the security details of the target. In most of the cases, the target is not aware of that. They cannot see you and they cannot block it because 90% of what we did is offline analysis using public data, open data, and using standard tools. The only difference is that we had to code some of the tools manually to create them in a way that can read all form of document that we want, but all this is available and is public. Why it's related to the visibility? Because it's very difficult to estimate how to block or how to evaluate the risk of this. Everybody has to disclose something, and this is an implicit risk. So what you say to the public, to the internet, always exposes a part of your security and basically can show how you do things. By the way that you do things, people can infer how they can exploit this and try to see what can be done with the information. And we're done, way in advance. So if anybody interested in the slides or in the content, get in touch. I will put the slide public. I'm in Discord. And does anybody have questions? Anybody? An idea, comment, something? Well, thank you for listening. No question, not from the chat, not from anything? if anybody wants to get in touch, here is my mail, the slides. And if somebody interested on doing anything with us or has a clever idea, again, get in touch. And anybody has technical things that want to discuss?
There's no question for now, but there were like thanks, good presentation. So as again, people can go and talk to you in the Discord channel just for that. So no problem.
Okay, so thank you again for having me, and I leave you to the next presenter.
Thank you very much.
Thank you. Bye.